Hi friends, in this video let us solve the single system related question asked in GATE 2019 paper. The question is a LTI system with the impulse response h of t produces output y of t when input is x of t. So when input is x of t, it produces y of t, impulse response is h of t. When input is h of t minus tau and impulse response is h of t minus tau, what is output? So when input is x of t minus tau, impulse response is 1. What is output? That's what they are asking. We know output is the convolution between input and the impulse response. X of t minus tau, h of t minus tau. So what I do? I want to find y of t. I take Laplace transform, find y of s. Then I take inverse Laplace. Because Laplace transform converts convolution into multiplication. So that is easy to work. So for x of t minus tau, Laplace transform is x of s e power x tau. Convolution will become multiplication. H of t minus tau is h of s e power minus s tau. So y of s is equal to x of s, right, into h of s e power minus 2s tau. So from this what we are understanding, it is y of t. I take inverse Laplace. Y of t is, what is the thing? This is x of s, h of s e power minus 2s tau. When it is shifting property of Laplace transform, when it will come, it is x of t minus 2 tau. H of s, we can call it as inverse Laplace h of t. Here it is dot, so it will become convolution. So what is the input now? So input is x of t minus 2 tau. So what will happen? So the output will be equal to y of t minus 2 tau. So I can say it is input is shifted because it is LTI system. So the output will also be shifted. So y of t minus 2 tau, right? So that is the answer. So option y of t minus 2 tau, option D is the right answer, right? So how did I put the left hand side is y of t minus 2 tau? Input shifted, shift in input. We know what is time invariant system. If there is a shift in input, then output will also shift. That is what time invariant system. So I use that property. So output is y of t minus 2 tau. Thank you.